8. We're looking at polynomial division and factors, and this is the last set of notes for the year 2022. All right. Quick refresher on vocabulary. Dividend divided by divisor equals quotient. So the quotient is the answer in a division problem. The divisor is what you're dividing by, and the dividend is what's being divided. Okay, so it shows it in 3 different ways that it could be written. Long division, as a fraction, okay? We do need to review our long division process. This is an easy question. I know you could do it in your head, but we're reviewing a process. So if I want to divide this, I am going to first ask myself, what is 14 divided by 2? And I would put that on top, and then what would I do with that 7? I would multiply it by the 2. 7 times 2 is 14, and then I would put it down here, right? And then what would I do? So I subtract, and that's 0, and then I bring down the next term, and then I do it again, right? I say, okay, what's 6 divided by 2? And then I multiply that by 2, and that's 6. And then I subtract again, and I get 0. That means I have a remainder of 0. This divided out evenly. 73 is my quotient. Does everybody feel okay with the long division with integers? It is the exact same process with polynomial functions, okay? This gives a breakdown. This is just a screenshot from your textbook. The main thing you need to get from this is that when we give our answers, we are going to write the quotient plus the remainder, if there is one, over the divisor, okay? If there's no remainder, you would simply write the quotient. That would be your answer. But if there's a remainder, this is the format that it's written in. Quotient plus remainder over divisor. Okay, if you want to check your answers, you can take the divisor times the quotient plus the remainder, and it should get you back to the original function, the dividend. Okay, so it's a way you could go through and check if you wanted to. This says the exact same thing, but in function notation. It is saying you will write your quotient, they're just calling it Q of X, plus your remainder, they're calling it R of X, over your divisor, which they're calling D of X. That just means the same thing. When you do polynomial division, you have the dividend divided by the divisor. It's going to be quotient plus remainder over divisor. And this says the same thing about checking your answer right here. It's just in function notation. Now, when we do polynomial division, we do have to make sure that our polynomials are written in standard form, meaning highest to lowest degree. Okay, so the x cubed, then the x squared, then the x, then the constant. Okay, so if there's something missing, we have to use placeholders. So for instance, if I had x cubed plus x minus 1, and I wanted to divide that, when I write it out to do the division, I have to put in a placeholder for the missing x squared term with a 0 coefficient. 0x squared. This is just a placeholder. And I would write it like this, in highest exponent to lowest, all the way down to the constant, with 0 coefficient for placeholders. Does that make sense? All right, so let's try it. I'm going to factor this function completely using long division if x minus 3 is a factor. If it is a factor, that tells us we should get a remainder of 0, okay? If they're telling us it's a factor and we divide it and we get a remainder, we've probably made a mistake somewhere. Okay, so I'm going to write out 6x cubed minus 25x squared plus 18x plus 9, no placeholder needed, divided by, and then x minus 3 is the divisor. Okay, now we're going to go through the same process we just reviewed. we focus on just the leading term of the dividend and divisor. Now, I'm going to be doing scratch work off to the side, so you can look back at your notes and see where numbers come from. But when you get the hang of this, you don't necessarily have to do this off to the side. I am asking myself in my head, what is 6x cubed divided by x? And it's 6x squared. So that's going to go in my quotient on top, and you align things. This is a squared, so it goes over the squared term. Okay, then I multiply that by the divisor, just like I did when it was an integer. But this time my divisor is a binomial, so I have to distribute that to both terms in the binomial. So 6x squared times x is 6x cubed, and 6x squared times negative 3 is negative 18x squared. Okay, and then what was the next step when we did this with integers? We subtracted. Now I have a little memory trick I use to help you remember, because a lot of people go to subtract and this is what they do. What do you think's wrong with that? That's only subtracting the first term. This term also has to be subtracted. Okay, it's like you have to distribute the minus to every term here. So this also has to be minus, and it's already negative. So minus a negative becomes plus, right? So what I tell myself in my head every time I do this step is draw your line and change your sign. So I draw the line underneath and then I change all the signs. Draw your line and change your sign. It's just a little rhyme to help me make sure I remember to subtract everything. Okay, so the 6x cubes cancel. Negative 25x squared plus 18x squared. So that's negative 7x squared. Okay, and then what was the next thing I did when it was an integer? I brought the next term down. So I'm going to bring down this plus 18x. Okay, and then didn't I start over? So I'm going to start over now with this lead term. I'm going to say, okay, what is negative 7x squared? And again, I'm going to jot this off to the side. You don't have to. Divided by x. And that should be negative 7x, right? Because this is the dividing by x is just reducing the degree of the x term. So negative 7x goes in the top as the part of the quotient. It's always divided by the leading term of the divisor here, which is just the x in this problem. Okay, so now the negative 7x gets multiplied by x, so that's negative 7x squared, and by the negative 3, so that's positive 21x. But then I draw my line and change my sign. So the 7x squareds cancel, and I have 18 minus 21, so that's negative 3x. And I bring down that plus 9. So then I'm ready to do it one more time with the negative 3x. So I'm asking myself, what is negative, what is negative 3x divided by x? And that's just negative 3, right? Okay, so that's going to go in my quotient up here, minus 3. Now that gets multiplied by the x, that's negative 3x, and by the negative 3, so that's positive 9. And I draw my line and change my sign. So this time both of those cancel. It's a remainder of 0, which we said at the very beginning, because they told us it is a factor. We knew we should get a 0 remainder, right? So that's good. That means that we did it correctly. So that means that my quotient is what's on top here. So 6x squared minus 7x minus 3. And they ask us to write this in, they say factor completely. So this is the quotient, and the factor that I took out was x minus 3. So this is a factored form of that polynomial. Y'all agree with that? If I were to multiply these back together, wouldn't I get back to the original dividend? Okay, so this is factored, but it is not completely factored because this is a quadratic and you can factor that further. Now, for the sake of time, I'm not going to review factoring methods with you because there's several different ones. We reviewed them last semester. There is factoring practice mixed in on your Delta Math. So if you need to go back and review factoring methods and techniques, that's in the Unit 3 folder on its learning. You can go to the completed notes in Unit 3. There's a video of the factoring refresher and there's a PDF of the completed notes of that factoring refresher. Okay, but what this factors out to is 2x minus 3 times 3x plus 1. And then you still have the x minus 3. So now that is completely factored form. Feel okay about that? All right, let's try one more long division. Make sure we've got the hang of it. This one needs a placeholder. What degree, what exponent term is missing? X squared. So I'm going to put plus 0 x squared and then the minus x minus 3. And then this is 3x plus 2. All right. So I am going to start with the leading term of the dividend and the divisor and ask myself, what is 9x cubed divided by 3x? And that's 3x squared. So that goes above the x squared. Good thing I had that placeholder for it, right? Okay, so 3x squared gets multiplied by the 3x and by the 2. So that's 9x cubed plus 6x squared. And I draw my line and change my sign. So the 9x cubes cancel, and that is negative 6x squared. And then I bring down the next term, which is the minus x. So now I look at this lead term. You see where you did something? Is this line in green good on yours?
Yeah, I'm just at 3, 2, 1. So I'm like looking at where she gets this.
Oh, okay. Yeah.
Yeah.
Okay. All right. So now we're ready for this to do the second, again, the process a second time. So negative 6x squared divided by 3x. So that's negative 2x. So that's my quotient piece. Okay, and then that gets multiplied by 3x. So that is negative 6x squared. And by 2, so that's negative 4x. And then I draw my line and change my sign. So that becomes plus and plus. 6x squared cancels. That is 3x. I bring down the next term, which is the minus 3. And I'm ready for one final go round. We ask ourselves, what is 3x divided by 3x? That's 1. So this is a plus 1 in the constant place of the quotient. So multiplied by 3x plus 2, that is 3x plus 2, right? I draw my line and change my sign. So this becomes -5. And there's no other term to bring down. I'm done. So this time I do have a remainder, which means 3x plus 2 was not a factor of this polynomial. It did not divide out evenly. Okay, now they don't ask us about factoring because it didn't come out evenly. We can't keep factoring, but we can write our answer, which we said we write our answer as the quotient plus the remainder over the divisor, right? So my quotient is 3x squared minus 2x plus 1 plus, and then my remainder is -5, and my divisor is 3x plus 2. I'm going to color code that to what we did earlier in the notes. Did quotient plus remainder over divisor. Now, that is kind of a lengthy process, long division, right? Okay. It's not necessarily difficult. It's just lots of steps. It's time consuming. So, and there's lots of places to make a mistake. Like lots of little mistakes can be made, even if you understand the process. You have to be very careful. Okay. Now, luckily, there is a shortcut for dividing polynomials that we can use. Some people like long division though, and if you want to use long division, more power to you, that's fine. But we are going to now look at synthetic division and do some practice with it. And I think the majority of people will prefer synthetic division and use it for polynomial division. Okay, but when we test or quiz on this, your choice on which method you want to use if you're asked to divide. Now, there is some practice on the Delta math, like there's a section that says long division and some that says synthetic division. You can use either one. Both will get you the same answer. I ideally would like you to practice at least a little bit of both. So maybe at least try one problem in long division and then you can do the rest in synthetic or vice versa. But on a test, like you get the same answer. It doesn't matter which one you use. Okay, it's your choice which you prefer. So this graphic just shows where synthetic division stems from, starting with a long division problem. You do not really need to know that, but you can look back on that to see where it came from. Now, on the next page, this key concept box gives you step-by-step instructions written out, okay, with an example next to it. So this is a good reference to come back to if you forget about the steps of synthetic division. Okay, so you take your dividend and you write out the coefficients. So 6, -25, 18, 9. Still in standard form, so highest degree to lowest degree, write out the coefficients. You would have a 0 as a placeholder if it was needed. Okay, and then your divisor, okay, this is in the format x minus c that synthetic division works. So c is this number being subtracted, in this case 3. Okay, it's what would make this equal to 0. It would be +3, right? So that goes in the little box out here. And then you leave an open space and draw a line. And then we start the process. You drop down the first term. It stays the same always. And then you are taking your c and multiplying by what's under the line. So 3 times 6 is 18. And then you add that column and you get -7. 3 times -7 is -21. And then you add that column. That's -3. 3 times -3 is -9. And then you add that column and you get 0. This last number you end up with is your remainder. So a 0 remainder means that x minus 3 is a factor of that polynomial. The rest of these numbers are the coefficients of your quotient. And remember, your quotient drops a degree each time we do the division, okay? So remember up here in the long division, we started out with x cubed. We divided out an x factor. So we went to x squared. It's always going to drop 1 degree. Okay, so let's try that process. And don't forget placeholders of 0 if they're needed. Okay, so my coefficients, I'm starting with x to the 4th. That coefficient is a 2. I don't have an x cubed. I need a placeholder for x cubed, so I put a 0, and then a -5, then a 5, and then a -2. Okay, so listing out those coefficients. Now here is my divisor. What is my c value? If this is x minus c, c is -2, right? So -2 is going to go in the little box here on the left side. Okay, and then we leave some space and draw a line. And then we're going to start the process. Okay, this is the setup. Once you have it set up, drop the first term under the line, stays as is. Okay, and then we are taking the c and multiplying by the number under the line and putting the product above the line in the next column. So -2 times 2 is -4. And then you are adding what's above the line. You're adding the column. So that's -4. -2 times -4 is +8. And then I add this column and I get 3. -2 times 3 is -6. And then I add this column and get a -1. -2 times -1 is +2. I add that column and that's 0. So this one means that this is a factor because I got a remainder of 0. Does that make sense? Okay, it divided evenly. Now, I need to still give my answer. Remember, this right here is my quotient's coefficients. Okay, so for the sake of the notes, I'm going to write this. You will not need to write this when you do this every time. But this was representing the x to the 4th, right? The x cubed, the x squared, the x, and the constant. Everything drops a degree. So now this is the x cubed, x squared, x, and constant, and this was the remainder. So when I write out my quotient, this would be 2x cubed minus 4x squared plus 3x minus 1. Quite a bit simpler, right? Still places to make mistakes. You can make silly mistakes multiplying and adding and subtracting. Be careful. Yes, that's basic math, but it's still common to make mistakes when you're doing that, especially if you're rushing. So be careful. Take your time. Now, what is different in B's divisor than in A's? And it's that 2. You're right. There is a coefficient. So synthetic division, it says up here, is used when we have our divisor in the or our factor in this format, x minus c. This is not in that format, is it? Okay, so there are 2 options for what you can do here. Okay, it's still synthetic division, but it's got an extra step that we have to do because of that coefficient. So I'm going to show you both methods, and you'll be able to choose which one you prefer from here on out. So option 1 is to divide out the coefficient, the divisor's coefficient, from everything. first. So that coefficient is a 2. So I'm going to divide everything by 2 to get rid of it. So that now I've got 5x cubed minus 13 halves x squared plus 5 halves x minus 7 divided by x minus 3 halves. Now that's in the format x minus c, right? So now my c would be 3 halves. So that's what's going to go in the box for my synthetic division. And I'm going to list out my coefficients. I don't need any placeholders on this one either. So I've got 5, negative 13 halves, 5 halves, and negative 7. Okay, and then I'm going to do the process. I'm going to drop the first term. Try and keep this color coded. Okay, and then I multiply. 3 times 5 is 15, so that's 15 halves, right? What's 15 halves minus 13 halves? They're already a common denominator. 15 minus 13. So what is 2 halves? It's a 1. So that's just a 1 here. So then 3 halves times 1 is 3 halves. So these are both positive. So 5 and 3 is 8 halves. What is that? 8 halves. 8 over 2. 4. Okay. 3 times 4 is 12. So this is 12 halves. What's 12 over 2? So that's just a 6. And when I add that, I get a -1 remainder. Now, here is the part that people forget. When they choose option 1 and they divide the 2 out at the beginning, they forget this last step at the end, which we have to remember. Because our answer is the quotient plus the remainder over the divisor, right? But my divisor, I have to go back to the original divisor. 2x minus 3, right? This -1 remainder is not the remainder for 2x minus 3. It's the remainder for x minus 3 halves. We got x minus 3 halves by dividing out the 2, right? So we have to, for the remainder, we have to multiply the 2 back in. So multiply the coefficient back into just the remainder. So this is times 2 for this particular problem. So my remainder is actually -2. So I'm going to highlight what option 1 was. So let me get a different color. So purple. So option 1 was divide out the divisor's coefficient from everything first, do your synthetic division, and then multiply the coefficient back into the remainder. Now you only have to do that if there's a remainder. If there was no remainder, you don't have to worry about that, right? Because 0 times anything, still 0. Agreed? Okay, so it's just if there's a remainder, you have to remember to multiply that coefficient back in. Okay, now option 2.
Interruption, teachers and students, just to let you know that we are now done with our testing environment. Most students are finished the STAR test. Great job this morning, students and teachers. Teachers, at this time, you may give back your cell phones, and students may be back into your normal environment. The bells are back on for the end of fourth period, and lunch will start regular time schedule. So thank you all. We are now done with our testing environment.
So they'll start ringing the bells again. So it'll be regular bells now. Mm-mm. Mm-hmm. Yeah, so rewrite the divisor in the form x minus c. Okay, so this 2x minus 3, we know if I were to set that, let me do this a different way. If I were to set this equal to 0 and solve, I would add the 3 over, right? And then divide out the 2. So it would be positive 3/2. So I could write this as x minus 3/2. Okay, and that means my c is 3/2, which that's what we got over here when we divided out 2 from everything. But over here in option 2, we're only focused on the divisor. We're not worried about the quotient. We just go ahead and figure out, and you may not have to write this down. Some of you will be able to do this in your head and say that means c is going to be 3/2. Okay, so we put 3/2 in the box. Okay, but we list out our coefficients as they were given. So 10, -13, 5, and -14. Okay, so I didn't do anything to the dividend. And I go through my process.
Yes, this does mean normal 5th grade class, normal A, B, C, D lunch schedule. So we're back onto a normal 5th grade class and normal A, B, C, and D lunch schedule. Thank you.
All right, so I went through the process. Okay, drop, multiply, add, multiply, add, multiply, add. Now this time, I don't have to do anything to my remainder because I didn't actually divide out 2 from everything, right? So I do need to divide out that coefficient from the quotient. So divide the divisor coefficient out of the quotient only. Don't touch the remainder. So that would be 5x squared plus 1x plus 4, because I'm dividing everything there by 2. Okay, but I didn't touch the remainder. The remainder is -2 over the original divisor of 2x minus 3. So the difference is I do my dividing by 2 at the beginning from everything, and I have to remember to multiply back in to the remainder. Or I do the dividing at the end just from the quotient. The 2 is this coefficient, yeah. And that's what we multiplied by here, because that was that coefficient that we divided by. Does that make sense? So either divide everything out at the beginning and multiply back into the remainder, or wait and divide at the end just from the quotient. So you can decide which one makes more sense to you, which one's easier to remember. Okay. All right. Yeah, I'm going to try and get through as much as I can. If it gets cut off, I'm going to continue the video though, so I can post it, and then we'll talk about the end of it in class tomorrow. Okay, so the remainder and factor theorems. Theorems and rules in math often are worded very confusingly. Okay, so the wording of this is saying that if your divisor, d of x, that's function notation for the divisor, okay, is x minus c, okay, with degree 1, that just means it's to the first power, okay, then the remainder is r. Okay, so that means f of x is x minus c times q of x plus r. That means the function is the divisor times the quotient plus the remainder, which is what we said earlier in the notes. Okay, so that's not really new, but it's saying if that's true, if that's the case, then if we plug in a c, whatever that c value is, if we plug that in to the function, we should get 0 plus the remainder, if there is a remainder. Okay, if we get 0, that means that it is a factor, that number is a 0, an x-intercept if we were to graph it. Okay, that's all the remainder theorem is saying. It's saying if I input the c value into the function, if I substitute it in and calculate it, I get r. R is the output. So if I input the c, the output is the remainder, is what that means. Okay, so we're going to look at that here just a sec in a problem. I'll try and explain it with an example. It makes more sense when we actually see it in work. But the remainder theorem indicates that you can divide f of x by x minus c using synthetic division. Okay, and the remainder will be your f of c. They're saying r is f of c. Okay, so it will come out, whatever your remainder is, that's your f of c. You doing that process using synthetic division to evaluate a function is called synthetic substitution. Okay, so you've done direct substitution for a long time, since pre-algebra, okay? When you know a value and you plug it in and calculate, you are substituting something directly into a function. So now we're going to look at that compared to synthetic substitution using synthetic division. And you'll see we get the same answer. Synthetic division works as well. That's what the remainder theorem tells us. So a couple of edits I made because I didn't catch this before I printed. One, I changed this to say Clear Springs football because I originally made this at my old school where I taught. And there was a typo here. On the printout, this is an equal sign instead of a plus sign. So you need to make sure you edit that in your notes, make that a plus. I guess when I was typing that, I just didn't get the shift key held down when I typed the button. Okay, so make sure that your equation is plus 68, not equals 68. All right, so it says the number of tickets sold during the Clear Springs football season can be modeled by t of x, and they give us the function, where x is the number of games played. So use the remainder theorem to find the number of tickets sold during the 7th game of the season. Okay, now it says use the remainder theorem. So that means do synthetic substitution to show that your remainder is your answer. Okay, but I'm actually going to do both so I can explain the remainder theorem a little better. So I'm going to show you direct substitution. Versus synthetic substitution. Okay, so direct substitution, they tell us up here that x is the number of games, and they're asking about the 7th game. So what are they telling us to substitute in? A 7. They're telling us when we have the 7th game of the season, we want to know how many tickets are sold, so we plug a 7 in for x. So direct substitution would just be input a 7 for all of the x values. Okay, and if I calculate this out, I doubt you want to do that by hand because you would have to be cubing this number, squaring it, multiplying by -14, multiplying this one by 72. Okay, kind of a lot of work to do by hand. So I'm going to save us some time and tell you this comes out to 229. So at this after 7 games are played, there are 229 tickets sold. Okay, so that's direct substitution. So what the remainder theorem tells us is we can also get that answer doing synthetic division. So I'm going to list out my coefficients. I'm going to do this in a different color here. I'll do it in blue, I guess. So my coefficients are 1, -14, 72, and 68. And then a 7 is my C. That's what goes in the box. And if I do my synthetic division, drop the 1 times 7 is 7. That's negative 7 times 7 is negative 49. That's 23. Times 7 is 161, which comes out to 229 as the remainder. How about that? We got the same answer as our remainder as we got doing direct substitution. This was easier to do in my head. I did this in a calculator, right? If you have a calculator, sure, direct substitution may be just as quick or quicker. But this, I just wanted to show you that synthetic substitution, synthetic division, the remainder is your output. If you input your C into the function, the remainder is the output. That's the whole point of the remainder theorem, is to understand that that's what it represents. Yeah, you'll have like a basic, yeah. Now, if you use the remainder theorem to evaluate your function at x equals c and the result is 0, that means if we got a remainder of 0, we know that c is a 0 of the function. It's an x-intercept. That would mean that x minus c is a factor of that function. So like in the example we just did, I know that x minus 7 is not a factor of that polynomial because that was not a remainder of 0. Okay. Now this leads us, knowing that that's a factor, if that comes out to 0, gives us the factor theorem, which says that this is a factor if and only if f of c is 0. So in the last examples here, they just want us to test these factors and see, are these actually factors, these binomials? Okay, so yes, I could take my c value. So if it's x minus c, this means c is 1, right? And here c would be negative 3. So I could take a 1 and do direct substitution in here and see if I get a 0. If I got a 0, that means that this is a factor. If I substitute in a negative 3 and calculate this and get 0, that means that this is a factor. That's direct substitution. But we're going to do synthetic substitution because they want a factored form. So we actually need to divide it out and see what the quotient is. They're not just asking for a yes or no answer. Does that make sense? All right. I'll see y'all. Those of you watching this video, I guess I will stop this here and I'll do it as a separate, I'll do example 5 as a separate video in another class.